All right, guys. It is Saturday afternoon. I'm going to work a few of these practice test problems and just show you how they are derived from this page 7, the Gibbs free energy page in your notes. We didn't talk too much about this in class, but we're basically going to use these two equations to answer the questions. All right. This question right here, this equation, they give us delta G at standard conditions. Right here, 642.9 kilojoules per mole. They give us the delta G at 298 for a reaction mixture with these conditions. Now notice that the temperature is still standard temperature, so we're not changing the temperature. We have this here. What we're dealing with is a Q value. Okay, because they gave us this delta G at standard conditions. They're giving us a new set of pressures, so that means we're really not at equilibrium at this point, but we can convert the delta G knowing that we're not at equilibrium, but we have this new reaction quotient. All right, so just plugging it into that equation. All right, delta G equals delta G standard, negative 642.9 kJs per mole. And these problems you can get mixed up on units and on conversion of joules to kilojoules. You already see right here that we have a place where we could make a mistake with units. And then here we have our ln of Q, and that's going to be products over reactants. So here's your PCl3. All right, we're squaring that, and we're going to divide by 1. I'm running out of room here, just bear with me. 1.6, that's the P2. It's not squared, it's just to the first power because of this balanced equation. And then right here we have chlorine has a coefficient of 3, so I'm going to take the chlorine. Oh, I've made a mistake. You see what I did here? This is P2 should be 1.5 there. All right, that's a 1.5 at this point. All right, for the P2. The Cl2 is 1.6 cubed. All right, so then let's see. We're going to solve here, and what I'm going to do before I go any further is make sure that I've converted this to kJs, and of course I just did that wrong. 8.314 times 10 to the negative third kJs per mole Kelvin, 298 Kelvin. All right, ln of all this stuff, and I am going to, our answer here is A, minus 649.5 kJs. I did not check it in my calculator first. If this doesn't work out, then I'll be right back. All right, that should be the end of number 1.